In this video, I'm going to tell you how many batteries you need for a 3000W inverter. The answer might surprise you because most people get this wrong. Then I'll give you two examples for a lithium and a lead-acid battery. I often see people using a 3000W inverter on a 12 mAh battery, which amazes me. No wonder the battery dies. After half a year, I'm going to talk about the battery voltage and capacity, which are the most important factors when sizing your battery. In an off-grid solar power system, you should limit the current to 100 amps. This has several reasons and benefits: reduced wire cost, cheaper charge controllers, higher efficiency. We can limit the current by increasing the voltage. That means that for each battery voltage, we can have a maximum inverter power range. These are for 12V battery inverters up to 1000 watts, 24V battery inverters up to 2000W 48V batteries, inverters up to 5000W SIF. You want more power, use a 48V battery with inverters in parallel. I will calculate it for a 3000-watt inverter. We divide 3000 WTS by 48 volts to become 63 amps. We then have to multiply by a safety factor of 125% to become 78 amps. We need to use an 80 amp fuse. This is under 100 amps, so this is okay. As already discussed, an additional benefit is that the charge controller current will be decreased, as you can see in the following calculation. 800 W of solar power divided by a 12 VT equals 66 amps. We choose for a 70 amp charge controller, but with a 48 volt system we can repeat the calculation and we will see that we only need a 20 amp charge controller. This will be much cheaper to purchase. Now, the second part of the calculation is a term called C rate. Every battery has a recommended C rate. This is 0.2 C for lead acid and 1 C for lithium. This is a recommended charge and discharge current of a battery. For example, a 100 amp hour lithium battery should be charged and discharged at a maximum of 100 amps. Because 100 amp hours, 1 C equals 100 amps. Let's repeat the calculation for lead acid 100 amp hours, 2 C 20 amps. We can see that a lead acid battery can deliver significantly less current. You can still pull 100 amps from a lead acid battery, but the battery won't last very long because heat will be generated and degrade faster. You also wouldn't be able to extract 100 amp hours because a lot of energy is lost in heat. Now back to the subject with an example for lithium batteries. We already know we need a 48 battery. Next, we need to calculate the current. It will draw 3000 W48 volt equals 62.5 amps. This is under the recommended discharge rate of a 100 amp. Our battery, which is 100 amps, we need to use a 48 volt, 62.5 amp lithium battery. A 48V 100 amp hour server rack is an ideal example of a battery that is suited for a 3kW inverter. You can also use several batteries wired together, like 4 12V 100 amp hours wired in series, or 2 24V 100 amp hour batteries in series. There will be a link in the description to the lithium batteries I recommend. Now we will repeat the calculation for lead acid batteries. We start by doing the same calculations. 3000 watts divided by 48 volts equals 62.5 amps. 100 amp hour lead acid battery with a CK can deliver 20 amps. Next, we divide the battery current by 20 amps. 62.5 amps, 20 amps equals 3. We need 3 100 amp batteries for a total capacity of 300 amp hours. Because 300 amp hours, 2 C 60 amps, we need a 48 volt 300 amp hour lead acid battery to effectively power a 3000W inverter. This is 3 times the size than lithium and will weigh 1,000 compared to 110 billion for lithium. A possible battery configuration is 4 12D 100 amp-hour batteries in series, and then paralleled with 2 other strings for a 4's 3P battery. Always charge batteries fully before connecting them together. For lithium, you need a 48 hour battery, and for lead acid, you need a 48 300 amp-hour battery. Always respect the C rate of a battery to get the maximum lifespan. Thanks for watching this video. If you want more information like this, or you confused about solar power, get 7 free solar diagrams through the pinned comment below.